okay? So, given that I just said, the margin of error concept is going to be very similar to that 95% confidence interval, which is going to be very similar to being 2 standard deviations away from the average, right? 2 standard deviations away from the average is 95%. So it's just kind of a different way of phrasing it, and you're going to see as we look at some of these examples how that comes into play. So a recent poll found that 36% of all respondents would vote for candidate A in an election. Now, when you poll people, you're not polling the entire population. You're polling a sample. So, when the actual election takes place, do you expect there to be 36% voting for candidate A? No. It's probably not going to be exact. Will it be in the ballpark? Probably. Okay? I mean, perfect timing for this with the election we just had. Obviously, all their polls were wrong. They were clearly asking the wrong sample of people. The samples that they were asking, as far as who people would vote for, Trump or Clinton, the samples that they were asking were the media, that's who I mean by they were polling people that clearly were in Hillary country because everyone thought Hillary was going to win. And then what actually happened. So they were not taking a good random sample. They were taking a biased sample. Meaning, and I'm sure they were not doing this because this would just be stupid, but you never know. Maybe they were standing outside of a Hillary Clinton rally and asking those people, who are you going to vote for? Oh, look at that. 72% of them said they were going to vote for Hillary Clinton. So guess what? She's probably going to win. And that's what they led everybody to believe, right? The media. So at any rate, you have to make sure you're taking an unbiased sample when you take a poll, meaning you need to make sure it's completely a random sample, and only then are you going to get close to an accurate response, okay? And not only that, but you shouldn't just take one sample and go with that number. You should take 15 samples of 100 people and then average all of those together and go with that number, okay? The more you do, the better you are. So the poll reported a margin of error of 4%, okay? So what that means is that they're saying that the actual results they expect should be within 4% of that number. Now that could be 4 more than that number, or that could be 4 less than that number. So 36% plus or minus 4 means they are expecting that somewhere between 40%, if I do 36 plus the 4, or 32% if I do the 36 minus the 4. They are expecting, so with 95% certainty, this is my interpretation, with 95% certainty, the population will favor, well, let me take that back. Somewhere between 32% and 40% of the population. Somewhere between 32% and 40% of the population will favor candidate A. They're 95% sure of that. That's what their margin of error gives them. Okay? In exercise 2, I'm just sort of pointing out the similarity here. In any normal distribution, how much of the data falls within 2 standard deviations of the mean? 95%. What's that, Jake?
What's that? What's the word?
Right here, will favor candidate
A. I abbreviated candidate. Did I hit it for you? With 95% certainty, somewhere between 32% and 40% of the population will favor candidate A. Okay? Jump down to exercise 3. In a sample survey, 50 people were sampled about their favorite soda. If 38% of them listed soda A as their favorite, and the standard deviation of the sample proportion is 0.069. What is the margin of error? Okay, here's the big key. Margin of error is always 2 times the standard deviation. So in this case, that's 2 times 0.069. 2 times 0.069 on a calculator tells you that the margin of error is 0.138. So that's the margin of error, and then usually, almost always, you're going to ask to come up with an acceptable range of values, okay? So our sample tells us that 38%, but we do have a margin of error. However, you need to recognize this. Your margin of error is as a decimal, and your population proportion is written as a percentage. You either need to get them both to be percentages or both to be proportions. So if I were to, let's say I'll go to percentages, this is going to become 13.8% as my margin of error. Okay, so now if I'm this soda company, even though my sample showed that 38% liked soda A best, realistically the population is going to have a favorability somewhere within 13.8 of 38%. So that could be as high as, and on a calculator we would do 38 plus 13.8. That could be as high as 51.8%, or as low as 38 minus 13.8, 24.2. That's a pretty big margin of error, wouldn't you say? What percentage of the people favor soda A? Somewhere between 24.8 and 51.8. That's significant, right? Or 24.2 and 51.8. That's a pretty big margin of error. 13%, close to 14%, and therefore we get a pretty big range. So this soda company might want to do a few more surveys to really get a feel for what is the favorability, or maybe sample more people. Maybe 50 people wasn't enough to get a better, more condensed feel of where the actual population will fall. Okay? And these are very real things. Think about a company producing a new product and deciding whether or not they should go through with producing millions. You know how many different Cokes have come out over the years, right? Coke Zero, Coke, the ones that's clear, right? Wasn't there a clear Coke at one point in time? Crystal Pepsi. Like, they're just trying to come out with new things so they can market it and get people to buy it because it's new and try it. But, they kind of have to do studies, because that would be a lot of work to put out something that everyone in the world was going to think is disgusting, right? So they've got to do some samples, do some taste tests. How many of you have seen the commercials where they'll do a random sample, like outside of a grocery store, of, gosh, I feel like there's like a yogurt one where they like are tasting Dannon Greek yogurt versus the Oikos Greek yogurt, or whatever that might be, and then they're just showing that however many people, what percentage of people actually favored their brand. That's not uncommon. I think there's another one like with soap, Dove soap, and they compare it to like Bath and Body Works, right? And then they have people like, and then they take the top off and they're like, oh, look, you like the Dove soap better, that kind of thing. And they're running essentially samples. there's a lot of questions to be asked when they throw those percentages at you, though. How did they get that 80% of people prefer Dove over Bath and Body Works? We got to ask more questions. How did you run that study? How many people did you sample? How many times did you sample that many people? Like, there's a lot that goes into that. So it just makes you ask more questions rather than just believing everything that people tell you. All right. In a poll of 500 voters, candidate A led candidate B by a 46% to 39% margin. So let's kind of organize that. Candidate A had a 0.46 favorability. Candidate B had a 0.39 favorability. The standard deviations for both are the same. Could it be possible that these two candidates could actually tie? So we need to come up with the margin of error and then therefore the range of possibilities for candidate A. Because candidate A's result is going to be 46%, give or take some number. So, Alexis, what should I do first? Okay, and how am I going to do that? No, you're not going to multiply 0.46 times 2. The margin of error comes from taking the standard deviation and multiplying that by 2. What's the standard deviation? Right, so 0.022 times 2 is going to give us 0.044. So that's the margin of error, and then what am I going to do with that? Right, so it's like that 0.46 plus or minus 0.044. So the plus gives me 0.504, which if you want percentages, that's as high as 50.4%. And 0.46 minus 0.044, which would be 0.416, could be as low as 41.6%. So that's the range of possibilities for candidate A. Candidate B had the same standard deviation. Okay, so that would be plus or minus 0.044 as well. And 0.39 plus 0.044, 0.434. And 0.39 minus 0.044 is 0.346, or 34.6%. Okay, so let's answer the question now. Could it be possible that these two candidates could tie? Is it possible? No. I think so. Let's look at a number line. 30, 40, 50. Candidate A is going to score somewhere between 41.6 and 50.4. That's candidate A. Candidate B is going to score somewhere between 34 and 43. There's an ability to tie anywhere within here, right? Candidate B, if candidate B scores on the high end at 43.4%, and candidate A scores on the low end at 43.4%, they could tie. Of course they could. Yes? Do we see that? So, yes, they could tie. That's your first answer. Could candidate B actually win? Absolutely. Candidate B might actually perform at his maximum, and candidate A could actually perform at her minimum. This was probably the Donald Trump, Hillary Clinton scenario. Donald Trump got a higher percentage than his surveys suggested, and Hillary Clinton got lower, and guess what? They win. Okay? So yes and yes. Candidate B could have won, and obviously in the case we just saw, did win. Okay, flip it over. We're gonna skip, no we're not. We're gonna kind of partially do number 5. There's a little bit more to this I'm withholding from you because I think it will be more confusing for a lot of you than it will be helpful. But essentially here, we have a mean weight of 69.7 and a standard deviation of 3.2. We need to answer the following questions. We're going to skip A. And we're just going to assume the standard deviation of 3.2 grams. Okay? So 3.2, double that, is going to give you your margin of error, which is 6.4 grams. Okay? So jumbo eggs are supposed to have weights of 70 grams or more. The particular sample we just took only had a weight of 69.7. Is that within the margin of error? And since you have to be, you have to be within 6.4, your mean weight was 69.7, plus or minus 6.4. Which means 69.7 plus 6.4 is 76.1, and 69.7 minus 6.4 is 63.3. So, does that surround the 70? Yes, it does. Okay, so this is within our margin of error. Even though you need them to be 70 grams or more, you could have samples up to 76.1 or as low as 63.3. Okay? Any questions there? The last one, I would just have you cross out this. I gave you the standard deviation you're supposed to use at the end there. But we're not going to get to that one. I want you to finish that one for homework, and we'll talk about it. And here is your worksheet. Beautiful pilots for me. Thank you. You finish the one question on the notes, and you have to do the worksheet that was just handed out.